Hello everybody, welcome back to another video. I'm hoping you guys are all having a fantastic day. So in today's video, as you could tell by the title, I will be talking about the long range, kind of going over what different models are showing, what the Climate Prediction Center thinks will be happening, and where the heaviest rains will fall, where the heat will occur, where it will be cool. And yeah, as you could tell, I'm calling this an unusual, a unique pattern. I don't really know exactly what I'll decide on the title, what I'll call the video yet, but yeah, it's still a concerning pattern. If you recall, I made like the videos about that, but I kind of want to focus on a different part of the pattern, and that's why today's video isn't necessarily concerning or alarming, right? It's more of just kind of the unique way this pattern is setting up across the United States. Yeah, nothing historic. I've seen this before, but I mean, there isn't really any giant storm systems to talk about, any giant cooldowns, or there is obviously the heat wave and the heat across the west, but I just made a video about that 2 days ago. I'll probably make a video about that tomorrow. Again, today I just wanted to focus on this. So if you don't get it, I'll just explain it in just a little bit. But before we get into this, if you guys would like to support this channel, if you if you watch the video and you enjoy it, check out the other videos, check out the channel, consider subscribing, or if you're a returning viewer or new viewer, hitting the thumbs up button also helps out a ton, and leaving a comment. If you leave one, I probably will almost guarantee at least see it, and if not, answer it. I pretty much answer 95% of comments. All right, let's get into this. So notice, let's start off by looking at the GFS model. Let me just run this through rather quickly. Again, no real details, no real dates. I just want to see if you guys will notice something that I noticed, and I think pretty clear to notice it. So notice, as we push forward, we see again, no big storm system, right? But we see a northwest flow across the northeastern United States, not necessarily across the western United States, but look there. We see little fronts, little disturbances. Again, no big systems, no big storms. But as I push this forward, look, we just see a little wave after wave. There's another one you can see right there. There's another one that comes down. Another one right there across the central United States, followed by another low pressure dragged across the northeast, and then in the very long range we have this very large low pressure that circulates and brings actually supposedly some cool air, but again, this is very far out. But notice, right, it's interesting, and you can see that it's kind of keeping at a northeast flow, or northwest, depending on kind of which way you want to look at it. It's flowing from the northwest, but it's flowing down to the southeast. So yeah, and you may be wondering, okay, well, why is this? There's definitely an explanation. And there is. So if you recall, you probably do, I mentioned that there's a very hot pattern going on across the west. And there's a series of high pressures, ridges, and just the jet stream buckling over here. And what that does is it prevents any of these storm systems from going to the south, really, or kind of developing and pushing through this ridge. So what they do, they just kind of traverse down this kind of like a sledding hill, and that's pretty much what they treat it as. And a lot of these systems come down. Again, this will be breaking apart probably at some point or another during the forecast. And then, we can start seeing larger low pressures take a different track. But for a while, we'll just have these little disturbances, little short waves coming across, and again, kind of having their sledding adventures down the eastern United States, from acting or treating the kind of the northwest and the west as the hill part of the pattern. And I will show you the temperatures, and they pretty much resemble that pretty well. So let's take a look at the 2-meter temperature anomalies, right? And let's take a look at hour 00. So again, let's run this through. Notice where there is cool, it's across the east, the south, the north, I would say northeast, especially, maybe not the northern plains. But notice, look at that. We see very hot temperatures here, and it's a bit harder to see on a GFS that jumps around a bit more. But notice, that's where the heat is. While we do have some pockets of heat further towards the east, right, the more predominant, consistent heat, especially towards the longer range, you can see is right there. And we see those conflicting air masses. And that's why the storm systems are just riding to the south and east. And same with the air, with the anomalies of heat and the cool weather. Notice we have heat right there, slides to the south and east. We have cool weather right here. It slides off, gets replaced by either heat or warmth, depending on which weather model you look at, and that continues for a while. And if I were to show you the anomalies, which is many models combined, you would see this a bit more clear. Let's take a look at hour 0, 24, and notice, right, a bit of cool weather here, and we have that heat. Not really much cool weather, maybe a bit towards the coast at the beginning, but this heat starts taking place across the northern plains, and it dominates. Notice, it is less hot across the east, obviously, that's why, because there's a bit of a troughing going on, and then, but the heat across the west stays, and it is a bit jumpy at times, but generally that's where it is, and that's where it consistently stays. And that's why the storms kind of take this track down to the south, down to the south and east, and not necessarily take your classic like cross country systems like we've been having more of. So there's definitely something that I thought was rather interesting. In terms of a total accumulated precip, you could obviously see here's where most of the activity will be going on. The monsoons will be going on towards the southwest, kind of on the underbelly of that ridge. But notice where that ridge is across the northwest, southern Canada. It is rather dry. And again, this is one ensemble of 51 models, so some do bring a bit more wet, some a bit less, but generally you could see they're favoring the heaviest towards the south and east. And the GFS by itself, you could see pretty clearly distincts that heaviest rain towards the east and really drier conditions towards the west, excluding portions of Arizona, New Mexico, Colorado, and Utah, which could be thankfully a bit wetter as they need that. Now, if you're to take a look at different models like the Canadian, notice it does show a bit less of that. It's not as distinct, but it does show, again, a bit more precip towards the south and east, not much across the upper plains, a bit across the underbelly of that ridge, and right there flowing those thunderstorms. Notice, look at that, we have this band of pretty good precipitation, 1 to 2 inches of rain, and again, that will kind of spread and mix with moisture from the Gulf, and that's why there's more activity here. If you're to take a look at the Canadians' anomalies in terms of temperatures, the ridge isn't as visible, but the flow is still the same. Notice there is cool air here at the beginning across the east and northeast, but the warmth is definitely across Canada, southern Canada, and not so much the west, but it does move in there towards the end, but it also just moves more generally across the United States. Notice the Canadian, right? There isn't really a ridge, there isn't really a cool distinct air mass, but nonetheless it's still supporting the same flow. And again, I would say that the Canadian, it's way worse at predicting the temperature anomalies than say the GFS or the European. And I'll show you the European just a bit, but notice, right, notice the flow, it's still consistent from the northwest flowing to the south and east, and you can see a lot of them. Again, you can see right there, little disturbance flows to the south and east and then goes up the northeast coast. That one, look at it, again following that same trajectory. So you know, I wouldn't say super unusual, but definitely I wouldn't say common for summer. Maybe more of something you'd see in fall or maybe winter, but definitely something that is interesting to point out. I do want to take a look now at the European model and show you its precipitation outlook. Look, again, heavily favoring these states, the south, the east, again, that kind of conveyor belt. And then right here, a lot of it staying just to the north, again, because of that heat that will be staying there. If you're to take a look at the 2-meter temperature anomalies, just to show you where the hot air is, the heat of the heat, again, it's a bit hard to see where the blue is on this map. It's a bit less underdone than, notice, like right here, that's 10 degrees below average. And then if you were to look at the red, it's a bit more popping, even though it's the same kind of intensity right there. So regardless, let's take a look at this. Notice there's our cool weather. It is a bit scattered, isolated. It's not as uniform like in a one cool air mass you kind of see during the winter months. But notice we do have distinctly the heat, especially the severity of it intensifying towards the north and west. And if there is any cool air, it's towards the north and east. And you can see that that flow continues right there. And some of that heat with that flow does break out towards the end, and you can see the European kind of bringing it in across the rest of the United States. If you were to take a look at the precipitation type and rate, again, still the same thing, a northwest flow regardless of what the temperature exactly may look. Notice, again, no big systems. You see little tiny clusters of thunderstorms, little disturbances, little waves. Look at that one right there passing through the northeast, the Great Lakes, and eventually into the northeast. Another one right there through the plains. Little disturbances going at a distinct flow to the south and east. And again, this is going to be going on for a while. This isn't just like a 1 day or 2 day pattern. Just a consistent flow from the north and west. And notice that the south kind of flows a bit differently. It flows up along the east coast and this kind of converges and brings some of the heavy rain, the heaviest of the heaviest, along the coast and into the northeast, which may not really be a good thing. They've seen quite a bit of that precipitation. Now, I do want to take a glance at some Climate Prediction Center forecasts. Notice 6 to 10 day outlook. Again, they're favoring the heaviest of the heats for a bit further towards the north and west. And in terms of precipitation, they are favoring below average conditions generally across the east and the northwest. Now you may be wondering, well, didn't you just say that it's rainier across the north and the east and the south? Yes, but because there are no large systems and are just little scattered little buggers, if you will, right? It still will be wetter compared to other areas other than the southwest. much drier, I think, than the Northwest. I think this is kind of a bit overestimating some of these areas with its dry weather. But it's still gonna be the wettest in general. Like, look at the European, right? Let me show you what I'm talking about. 240 hours. It's definitely, you could see 2 inches, 3 inches. That's not necessarily above average, but it's definitely kind of this hot spot of the precipitation. Like right here, that's not really above average precip, but it's still more than what's going on across the Northwest, which could be completely nothing. And again, that's why I think this forecast may be a bit off. Other than, I agree with that above average across the Southwest. 8 to 14 outlook, really pretty much the same thing, just a bit less intensity because they're a bit less confident. But again, I do think it will be a bit wetter across the South and Northeast than what they're showing here. Again, they're not perfect either. It's hard to predict these things. I'm not perfect either. I probably will be wrong. They might be right. I'm just kind of giving you my thoughts. And notice, speaking of flooding across the Northeast, they are experiencing a lot of thunderstorms right now. I was looking at the radar, tons of flash flood advisories, flash flood warnings. They just seem to have, I was just looking at the weather there in Europe. They have been seeing, tons of activity. Notice, right there across the Northeast, Boston, Connecticut. Look at these storms. In the last hour or two, they just absolutely exploded. Look at that. Boom. Right there. Heading into Boston, Connecticut, Rhode Island. Just actually north of Connecticut, or northern Connecticut, northern Rhode Island. Look at that. Those are some powerful thunderstorms. They're very, very, very slow moving. And just, look at one location, Springfield, right there. They just got slammed by a thunderstorm. Probably more is on its way. Just a very, very moisture filled atmosphere, and you can see there's many behind here. Look at that. Philadelphia, Lock Haven, Williamsport, tons of areas just seeing storm after storm after storm. And again, that will probably continue. I think there will be several more of these instances, maybe not this widespread, but several more for sure into this upcoming pattern, as there will be these small waves, and they'll be converging from the moisture that's in the south, and it'll be riding up along the east coast. Look at this activity here. It's pretty impressive. Obviously, I wouldn't say a flooding kind of widespread massive event, but if a few areas do see localized rain one after the other, like we saw in the Northeast. Let me put the layers on for the flood and severe thunderstorm warnings. Yeah, notice there are quite a bit of flood advisories. Look at that flood advisory right there. Again, heavy range thunderstorms between 1 to 2 inches have fallen. That's actually the last time I saw so many flood advisories. It's been a while in such a small area. So yeah, definitely. Even if it doesn't look that active, I think there is still potential for it to be an interesting pattern moving forward. And I do also want to point out that I didn't focus that much on the temperatures in the long range, or kind of what I wanted to at the beginning of the video. I just decided to go stay more on the pattern, just divide it between precip and temperatures. But I do want to show you something that GFS is showing. So notice we've been having this whole summer these cool waves, right, just going down into the southern and eastern US. We might see a bit of a break during the next later half of July, but notice towards the end, this model of the GFS, look what it shows here. A very, very, very consolidated area of cool air. One that you would typically see in the fall or winter, or spring. Not necessarily the summer, especially July. It's definitely interesting to note. Not every model run shows it. This one did not as strongly. You can see it's a bit weaker. But the one for midnight definitely did. And notice, right there. There it is. There's that cool break of weather, and it showed quite a bit of that cool weather. It's very out, very far, but it's been several models now showing that. So it looks as if this pattern may continue, kind of what we've been seeing, and unfortunately that does mean more heat for the Northwest. Overall, this pattern is really not that organized. Again, I did say it was a unique and kind of more of an unusual pattern, but definitely not something that's extraordinary, in the sense that it's not something that's going to bring extreme impacts. Just more kind of unusual in the way it forms. Obviously, it's more summer-like to see pockets of cool, pockets of warmth, and the next day you can see it's pretty much in different locations further across southern Canada, and you put a bit further up and we see now heat replacing the cool weather across Canada. Now you see the cool weather replacing the warmth that was prior to the south. Yeah, so honestly it's hard to pick up any sort of pattern from this, but generally just a northwest to southeast flow, little bouts of precip, nothing too extraordinary. There aren't really going to be any massive storm systems as of now. Again, I could, coin some of these as, smaller, more potent storms, but in the near term, unless something big changes, there aren't really big systems. You can see it's just little small short waves, little cold fronts passing through, little small systems, maybe a bit more activity towards the end of the forecasting period, but again, just I would say an unusual, dry, calm pattern. overall. But if you're stuck under one of these little clusters, you could still get, a heck of a show. So that's kind of, I don't want to really disregard that as well. CFS, some folks ask me how accurate this is. Really, it's a pretty not that good of a model, very inaccurate, but I still kind of like to look at it sometimes just to see what it shows. It's kind of fun. Goes out very far, that's why. But notice what it does do, it keeps that northwest southeast flow for a while. It does eventually though shift it more zonal, and you can see it just starts going to the north at that point and some bigger storms. But yeah, I wouldn't really recommend looking at this model for any sort of detail, maybe just for the fun of it, which on this channel we kind of like doing. So yeah, thank you guys so much for watching, and I'll catch you all on the next episode. See ya.